Okay, 10-5, triangles. So we've again talked about triangles a bit here. They are polygons. They have three sides to them. I guess that's about all we really talked about with them there. What else do you need to know about a triangle? So we all know what triangles are. And as you can no doubt see on page 332 and 335, there are lots of triangles going on here. Over here, we got these lines on them here. Some don't have lines. Some have 2 lines. Some have 3 lines. Some have lines. Over here, we got different angle measures going on here. So, handful of different things we're going to cover today. So, we're going to start with the same way they start at the top here. Now, when you're talking about triangles, there are different types of triangles out there. They all are triangles, but generally in geometry, we take it a step further than that. Just saying, well, it's a triangle. Well, thank you, I know that. But triangles can be classified in 2 different ways. They can be classified by their sides, which of course are these right here. There's the sides, 3 sides to any triangle. Or they can be classified by the type of angles that are in them here, knowing what we know about different types of angles that we talked about earlier this chapter here. So we'll just start, go in order here, kind of focus on 1 through 8, but when we're talking about classifying triangles by their sides, classifying triangles by their sides. Okay, there are 3 different types of triangles going on here. So first is the equilateral, which is probably the easiest of the 3 to understand because it kind of has the word equal in there a bit. And when you think equal, you think, well, everything's equal to each other, and that's exactly what an equilateral triangle is. What it's telling me is all 3 sides are the same length. So if this was, say, 3 inches, well, this is 3 inches, and this is 3 inches too. So I'm just making up a number here. But all 3 sides have the same measurement, whatever it may be. 10 inches, I mean, it doesn't really matter here. But beyond that, we get introduced to these tick marks here. And that's what these lines are all about here, these tick segments here. So if I put these 3 ticks here like this, see how I did that there, just kind of these 1 lines that go through it there, that is the symbol for congruency. Meaning, again, when we talked about congruency, congruent basically means equal. So I don't need to write all sides are 3 inches. Instead, I could just write that this is 3 inches, throw the tick there, there, and there. By definition, seeing this line here, that tells me they're all 3 inches there. Okay? You don't need to write this down here, but very briefly, because they show some with others, but there's a rectangle. Okay? And if I saw something like this, and then something like this, what do you think that would mean for the rectangle there if you saw something like this? I'll tell you this is 5 inches and this is 10 inches down here. What do you think the measurement of this side would be?
5.
How do you know?
Because the other side is 5.
Right, you see there's
And
that
there's
1
the
tick.
mark.
Now what about this side up here?
10.
Right, it would be 10. And again, it's not 5. If it was a square, for example, well, all 4 sides would be the same and I'd just use the same marking. But when you deal with these tick mark type situations here, anything that has 1, all those are the same. But if there's another dimension or measurement that's also the same, well then we use 2. I mean, I could have 3 tick marks if it was a much bigger figure. And then anything that had the 3 lines, those would all be the same measurement as each other. Does that make sense there? Right, and again, we'll see this a a little bit more like in tomorrow's lesson when we deal with the quadrilaterals here, kind of how that works there. But basically, anything that has one line, you'll know the measurement of that. Then anything that has the one line has that measurement. And then anything that has two lines, well, that'll be a different measurement than anything that has one line. But anything that has the two lines, they're all the same measurement, and so on and so forth here. There's really no limit to how many lines there can be, but honestly, up through 8th grade, you'll never see anything that has more than 3 lines in it. So, and even in high school, that would be a little much. So there's better ways to represent information if there's that much going on. So anyway, when we're dealing with classifying things by the sides, we're really interested in looking at these lines here. Because you can see 1 through 8, when we go through these here, there's no numbers anywhere. We don't know any of the measurements here. So instead, what we're focusing on is looking at the lines. In an equilateral triangle, it will have 3 lines because all 3 sides are going to be the same. Basically, if I give it a definition here, all 3 sides are congruent. And again, it's generally the easiest of the 3 to remember. Equal, all sides are equal, so most people do pretty good identifying equilateral triangles. The other 2, though, it's easy to get them mixed up here, to be honest with you. Just there's no real easy way to remember them. You'll be best served if you can just try and, as you go into your quiz and test, you'll want to know all 3 of these here, but whatever method you need to use to just try and keep track of these last 2 here is good. So number 2, the isosceles. And no, you don't have to worry about spelling it right on the quiz or test here, but that's officially how it's spelled. ISOSCELES.
For like the homework, could we just put like the first letter of their name? Like I, E, or S.
IE or SARO, probably.
Not even going to.
So isosceles has 2 of the 3 sides congruent. So an isosceles triangle, 2 of the 3 sides will be marked congruent. So I could draw something, I don't know, like that. Maybe that wasn't the best one. There we go. Draw that. There you go. That one looks a little better. So, or that one there. That one looks a little equilaterally. That one doesn't. So, when you're talking about an isosceles, 2 of the 3 sides are identical. The 3rd side will be not. So, there's the difference. And of course, that only leaves one thing left here, the scalene. None of the sides are congruent. Or all the sides have a different measurement. And again, I can draw that, and that. It would be certainly one here. That's going to be the longest side, longer than any other here, but you will see no marks of congruency because none of those 3 sides are the same length to each other. They're all different sides here. Getting this all down, Uriah?
Yeah.
Oh, okay. I haven't seen much pencil moving recently. Seem kind of like you're zoned out on me here at the moment. So all 3 sides are different. So really it comes down to looking for these tick marks. If I see 3, well then I know all the sides are congruent, therefore it must be equilateral. If I see 2, well then I know 2 of the sides, but not the 3rd one is congruent, that must be isosceles. And if I don't see any lines whatsoever, well then it's a scalene triangle. None of the sides have the same measurement. Okay, so E to U and 8 triangles. How about that, huh? So each of you, I'll pull a stick here. There they are. You don't need to write it down here, unless you really want to. But we should just be able to peel through these, I think. Apply the right definition to the appropriate triangle. Look at the tick marks. Use that as your reference. So number 1, what type of triangle is that? Stella? Isosceles, right. 2 of the 3 sides are congruent. Number 2, Michaela.
Number 2,
How many sides are congruent? You see any of these tick boxes?
no,
So that means no sides are congruent, or they all have different measurements. So which one would that be?
this
Scalene,
triangle, scaling.
right, scalene. Number 3, Roland.
Would that be isosceles triangle?
Would be an isosceles, right. Again, little weird. I don't know why they use 2 tick marks all of a sudden here. It's generally, you start with 1, and then if you have a second set, then you use the 2s, but yeah, I don't really know. I mean, generally speaking, these would all just be 1s here, but I don't know why they do it that way, to be honest with you. But generally speaking, if you only have 1 set of congruent sides, you just use 1 tick. You know, just skip the 1 and go to 2 here. Anyway, number 4, Noah. Yep, equilateral. All 3 sides are congruent there. Number 5, George. Yep, another equilateral with the random 2 bars all of a sudden. Number 6, Lauren.
Number 6, that would be scaling.
Scalene, right. No sides are congruent. Number 7, Ella. Yep, equilateral. Number 8, Uriah. Isosceles, right. So, there we go. Not hard to do. Again, the hardest part when it comes to quiz or test is keeping isosceles and scalene straight in your head about which ones are which here. I've yet to find an easy way to remember those 2, so nobody has found a great method yet either that I know of. So just at some point before the quiz, you may want to just consider looking at this one more time. Just make sure you know which one's which going into your quiz or test here. Not hard. Obviously, you know they're different. It's one or the other. It's just trying to remember which one it is. Okay. Good with that? So that's how we classify them by sides. That's how we classify them by sides. So now, shifting gears here, we can certainly classify them by sides, but triangles can also be classified by their angles. Once you get into 7th grade, you'll classify them both ways all at once. So we'll talk about that in a minute here. So the 3 parts, classifying triangles by their angles. Right, what are you doing there?
I don't know.
Doing notes here. Looks like you're playing with your protractor.
No, we're trying to figure out an angle.
Classifying triangles by angles. There are 3 of them. So, a right triangle. The right triangle has exactly 1 right angle. And if I draw that, you know for sure that you're looking at a right triangle because, again, you'll see that square box there. We've talked about the square box before when we talked about perpendicular lines, 90-degree angles. That square box is a guarantee that you're looking at a right angle. So when you're dealing with a right triangle, again, we'll usually have the square box. Right there. So that's what you're looking for here. Just like when we classified angles, acute, right, obtuse, or straight, when we saw that box like this, we knew right off the bat. It was a right angle, exactly 90 degrees, perfectly up and down. All right, so if you see a right angle, that's a right triangle. 2, acute triangles. All 3 angles are acute.
Maybe two know what you want. Maybe two know what you want.
So this would be a good acute triangle. I mean, if I look at each angle one by one, none of those look like obtuse angles. There's no marking telling me anything's a right angle in this triangle, but that angle, and that angle all look like they're less than 90 degrees. So all 3 angles will be less than 90 degrees. We're going to talk about the total degree measurement of a triangle in a minute here, but bottom line is all 3 angles are less than 90 degrees. All 3 angles are all 3 are acute angles. Okay? Third, the obtuse triangle. Has one obtuse angle in it. Of course, obtuse angles are greater than 90 degrees, but less than 180. So something like this would be an obtuse angle, or obtuse triangle. Again, I don't see any right triangle symbol in here, so that's out. But this angle right here, right there, that looks bigger than 90 degrees to me. And any angle bigger than 90 degrees is obtuse. So if I see one obtuse angle, well then it's an obtuse triangle. If I see one right angle, well then it's a right triangle. And if I don't see any angles that are obtuse or right angles, well then it must be an acute triangle. All triangles are one of these 3, just like classifying by size. As I said, in future years, 7th grade, you'll have to classify both ways. I'll draw a triangle and it could be an acute isosceles or a right scalene or, any combination of. So ultimately, we'll build into classifying them by both angles and sides at the same time. That's just a very specific description of different types of triangles. What do any of these descriptions matter for? Well, much higher level math down the road, depending on the types of triangles, it has different types of properties, which allow you to find a lot of different types of measurements for them here. Not quick or easy to sum up here, but all these classifications do mean something. They all have very unique properties depending on the sides and the angles and what you can do with that information. So getting comfortable with what they are, being able to name and identify them is the first step. It's important. It's something you'll need to be comfortable with in your later years here, especially high school, that you'll be able to do this quickly, fluently, and accurately every time. Okay, so same deal, 9 through 16. We'll run through it one more time here. The 8 of you, 8 triangles. Works out just great, doesn't it? So everybody gets one here. Looks a little fuzzy to me. Refocus. There we go. Not so fuzzy now. Much better. Okay, so same deal. Tell me, is it a right triangle, an acute triangle, or an obtuse? Again, no tick sides or anything here this time because we're not looking at the sides. That's what we did up here. This wasn't classifying by angles, so again, we're not interested in the sides here. It's not isosceles, scalene, or equilateral. That's classifying by sides. Now we're classifying by their angles. So those are your three choices here. Number 9, what do we got there, Noah? Yep, right triangle. Again, once I see that square there, that means it must be a right triangle. Number 10, Roland.
That one right there, that's
Obtuse, right. This angle here looks bigger than 90 degrees to me. Number 11, Stella. Acute, right. All three of these angles are acute angles there. Number 12, Uriah.
Number 12 is obtuse.
Obtuse, right. That angle is bigger than 90 degrees. Number 13, Lauren. Another obtuse, right. That guy right there is bigger than 90 degrees. Number 14, George.
number 14. Right angle.
Right triangle, yep, there's my right angle. Number 15, Ella.
Put John on the desk.
Number 15.
That is acute.
Acute, yep. And Michaela, number 16.
Number 16, right.
Right, right triangle. Whenever I see that box, that's a right angle, that's a right triangle. All right, good with that? Classifying by angles is usually not too hard, especially. All right, George. Classifying by angles is generally easier. I mean, we already covered all these angles before. You guys seem pretty good about it when we did it a couple units ago. Again, as long as you can keep track of what acute, right, and obtuse is, most people can. So, feel good about that? Okay, next side. So, now we're going to start dealing with measurements of a triangle. Okay, so does anybody know how many degree measurements a triangle has?
Actually,
No? What is it?
180.
180 is correct. So a triangle
I bit onto that. I had that in my mouth before. I can really see the bite mark.
measurement of 180 degrees. Vital information here, truly. We're going to go through, in 7th grade, we'll learn a formula to figure out degree measurements, total sum of the angles and stuff like that. But what that tells us here is for any triangle, and I mean any triangle, if I add up this angle, whatever it may be, plus this angle, you will always, if you sat around with your protractor and measured all three angles in the triangle, specifically, they will always total 180 degrees. This angle plus this angle plus this angle equals 180 degrees, always in a triangle. Doesn't matter what the angles are, if it's obtuse, right, whatever, the sum of those three angles will always total 180 degrees. Always, always, always. Okay? So knowing that here, totals 180, we can look at 17 through 20 here. So 17 shows us this right here. Again, just kind of loosely sketching it there. Not only does it say 90 degrees, but it gives us the right angle box too. And 30 degrees. So that's what it looks like right there. These little arrows are not really necessary, but they're showing that this angle here is 70 degrees, that's 30 degrees. Probably could have figured it out without the arrows, to be honest with you. So the question is it possible for this triangle to have these measurements, and how do we know? Roland is giving me a big one of these here, so he doesn't think it's possible. Why not?
Because 9 plus 7 plus 3 is like 19.
Yeah, if I add up these three measurements, I go 70 and 30, that's 100, and 100 plus 90 gives me 190. And what did we just say about triangles? They have to be 180. Right, if I add up these three things here, I get 190 degrees. So the answer is no, this cannot be the measurements of a triangle. That's impossible. Has to be 180. Not, right, no.
No.
Very, very much no here in this situation. So all we really need to do here is add up our three values. If they total 180, that could certainly be measurements of a triangle. If it totals anything else, well, the answer is no, because triangles always have a total degree measurement of 180. So add up the three numbers. If they add up to 180, that could be a triangle. If they add up to anything else, definitely not a triangle. Okay? So don't think we need to write them all out here. But number 18, you can check it, look at it, ponder it. Could those be the possible measures of a triangle? Uriah.
Number 18?
Right.
No.
Why not?
20 plus 50, 35 plus 100 is 103.
Yeah, that totals 135, and once again, it's got a total 180. What about number 19? Noah? Yeah. This is an equilateral triangle, by the way. All equilateral triangles, not only will all the sides be the same, but all their angles are always the same too. And they're always 60 degrees. So an equilateral triangle always has three 60-degree angles in it. Always. So that is an equilateral triangle. Right. It's an equilateral acute triangle. Equilaterals can only be acute. There's no other choice because they can only be, all angles are the same, all sides are the same, but equilateral. Equilateral triangles, 360-degree angles. Number 20, Michaela.
Number 20? No.
What's 8 plus 2?
9.
10. And what's 10 plus 8?
10 plus 8. 90.
10 plus 8?
98.
18.
Yeah, I'm on 18.
So 180. So yes, yep, that one it could certainly be. Sum of the three angles 180. Got that? Easy enough here. Right, okay. Last part. So now pull it all together here. 21. So draw kind of roughly a triangle here. They tell me this is 85 degrees. They tell me this is 80 degrees. And the question is, well, what about that one over there? What's the measurement of that last side? Anybody have an idea how I could figure out what this is here? I'll hear from George. George, what do you think it is?
85 plus 80 is 165. So
Yep.
minus 180 equals 35. I know.
You're so good, George. Except for that last part there. You're right. So 80 plus 85 is 165, and then 165 from 180 is
165 from 180 is 15.
15. That's exactly how you do it there. So good attempt,
I was
Rob.
being
Good
rueful.
attempt there. So right.
Yeah, you were.
So that's exactly how you're going to want to do this. So we know that a triangle's total degree measurement is 180 degrees. We know that to be true. So you could do this a couple different ways. I could subtract 85, or I could probably just subtract 80. That would be a little easier first. And then I have 100 degrees. And then I could subtract the other one. And then whatever I'm left with must be whatever it is, because 85 plus 80 plus 15 is 180. So there's my missing thing. Or you can do it the other way. You can add up the two that you already know. 80 plus 85 is 165. and then merely just subtract that from 180. And once again, you'll end up with 15 degrees. Both ways are perfectly acceptable. Pretty easy to check your answer too. I mean, you just, hopefully this plus whatever your third measurement is, total 180. Not too hard to check these either if you're so inclined here, but whether you subtract twice or add the two that you know and subtract from 180, if you get to 15, I like how you did it. I like how you did it. So why don't you guys try the last three here? 22. Again, roughly sketch them out here. 35 degrees, 40 degrees, in degrees. How much is that? 23. Says 65 degrees, 65 degrees. That, 24.
What now?
Does kind of look like no.
No.
But,
No.
right, very good. Very good. So, I'm just using it because that's the letter they are using, so, you know, but, either way, we're solving for n, we're figuring out what the missing degree measurement is here. So on your own, figure out what 22, 23, and 24 is.
Oh, don't say that.
Why?
Chico.
Yeah.
And we'll probably look at the two word problems. They take a little thought.
Or did
Not
we-
impossible. Well, I conveniently have 5 sticks left and 5 problems, so this works out well.
Oh, so we are doing the work.
Very
Right.
convenient.
Right. And we got time, so it works. It really does work out. Okay. First, let's do these 3. And see what we come up with here. After this is our last lesson on triangles here. Then we're going to shift gears tomorrow, and we're going to talk about four-sided figures tomorrow, quadrilaterals. Different types of quadrilaterals and properties of them, so a little more involved. So trying to remember all the criteria and classifications can be a little challenging with tomorrow. So, but. All right, 22. What am I missing for a degree measurement there? What's n? George?
22. Number n is 110.
Well, that's 35 and that's 40.
Yeah.
So 30
75.
from 180. 180 minus 75. 180 minus 70. Yeah, 105. 105. That's what we should have there. Yeah, if you did that, you would have 180 minus 75. 105 is correct. 23. What are we missing? Lauren.
Yes. 110 degrees.
110. What?
Oh.
What's 60?
Oh, 70.
What do I need to do to solve it?
So you 65 plus 65.
Is?
Oh, come back to me.
Or what's 65 plus 65?
Well, yeah, but I didn't do my whole thing. Okay, so 65 plus 65, the 5 and the 5 is 10, and then the 6 and 6 is 12, and then 13, 130.
Yeah. Then what?
And then
Yeah.
180 minus 130 is 50.
There you go.
No,
That's what we need there. Right. 50 degrees. That's what we're missing there.
donuts.
Right. 50 degrees.
Wow.
I knew you had it in you, Lauren. 50 degrees. Right. That's what we should get. 24. Roland.
I think it's 60 degrees.
Right. And again, if you remembered equilateral, all three sides will always be 60 degrees. So 180 minus 120 if you so chose, but 60 degrees is what we got there. All right, let's try 25. Let's see what you guys can do with it here. So, talking a triangle, I am telling you that one of the angles is 98 degrees. Another angle is half that. So what's the measurement of the third angle? I'll give you all a moment. I'll pull a stick there. Two people are all ready to go with their answers here, so.
One angle of a
Aren't you the
triangle
one drawing it?
98 degrees, and another angle half that.
Well, so one angle's 98. The second angle's half of 98. And therefore, the third angle is
Would be half of the second one, right?
No, you add the,
once you know your second, then you can just add those two together and subtract from 180 to find your third. So you need to figure out what half of 98 is. Then probably add that to 98 and then subtract that from 180. That should tell us what our third one is here. I'll sketch it out here. So I'll say that's 98. So help me out here, Stella. The one that's half of 98, how much is that?
49.
So we'll call that 49 degrees. Now I know two of the three. So what am I missing for the last one there?
Add 49 to 98, and then you get 157.
147.
And then 100, 80 minus 147 is 33 degrees.
There we go. So that's what that one has to be. So we got the 98. Half of 98 is 49. 98 plus 49 means 147. And then subtract 180, because the three are always total 180. Now I know what two of them are. So subtract 180 minus the 147. 33 degrees is what I got left there. One angle of a triangle is 105 degrees. If the other two angles have equal measures, what is the measure of each?
This one has to be caught.
One angle is 105 degrees. The other two angles are the same measurement. So I got a 105, and my other two numbers are the exact same number. What is that exact same number? 105, and then two more that are the same measure. How can I figure that out?
The other one, I did not understand. This one, I understand.
I
it
don't
makes no sense.
I don't understand this now.
Yeah. I understand
You
perfectly.
have to use the,
I don't understand how my pen exploded again.
Dear.
Again. Well, I understand how your brain is
How can I figure it out? All right, who's up here? Ella. So I got, we'll call that 105. So what do you think? What do you think it is? So what do I want to do first here? Would be a good first move here. That's what I would do first. Right, I'd say, and what's 180 minus 105?
I had no idea how.
What's 180 minus 105? You can do that. And that is exactly what you want to do first. 75. So now, this 75 degrees here, I know that half of it goes there and half of it goes there. But when I add up these two numbers, I'm going to get an answer of 75. right? This plus this is gonna equal 75. So what can I do with 75 degrees now? And how do I cut something in half? What do I divide it by? Right, so now I set up a little division problem. What's 75 divided by 2?
2 is 75. 3 times, which is 6. Subtracts 7, which is 1. Bring down the 5. Then it can go into it 7 times. It's 37. That's 14. Subtract that. You have a remainder.
I don't want a remainder,
So
which,
then you're going to add a 0 at the end.
right, but first I need to add a decimal. Because otherwise I wrote 750, I want. So, okay, drop that.
And then that's a 5.
So now I know half of that is 75. So what's the missing measurement for both of these here?
37 and 5.
Right, that one's 37 and 5/10. That one's 37 and 5/10. 37 and 5/10 plus 37 and 5/10 is 75. 75 plus 105, there's my 180 degrees. See, you could do it. You got
Like
it.
and subscribe.
Thanks,
First,
Like and subscribe.
or